So dear students, now let me discuss about Bernoulli equation. In the last class we have discussed about Leibniz equation. Okay, that was popularly known as first order linear differential equation, and which is solved by using the integrating factor. And this is known as the Leibniz equation. But now let me discuss about the Bernoulli equation. So what we have discussed in the Leibniz equation, the form of the differential equation of Leibniz equation is nothing but dy upon dx plus py is equal to q. Okay, where p and q are the function of x. So this is nothing but the Leibniz form of first order differential equation. Now what is the Bernoulli's form? Bernoulli's form is something like this, that dy upon dx plus py equal to q into y to the power n. So this is Bernoulli's. This is Leibniz form and this is Bernoulli's form. So if you want to solve this equation, so what you have to do, you have to first convert this equation into Leibniz equation. So why you have to first divide this whole equation by y to the power n, and you will obviously get that y to the power minus n dy by dx plus p y to the power 1 minus n is equal to q if you divide this equation by y to the power n. Now what you have to do, you have to just put y to the power 1 minus n is equal to z. You have to put y to the power 1 minus n is equal to z. Now you will get, if you differentiate this equation with respect to x, then you will get just n, that is y minus 1 minus n, y to the power 1 minus n minus 1 into dy by dx is equal to dz by dx. Okay, so you will get 1 minus n into, this is y to the power minus n into dy by dx equal to dz by dx. So you will get y to the power minus n dy by dx is equal to 1 by 1 minus n into dz by dx. So you have to put here this y to the power minus n into dy by dx as 1 by 1 minus n into dz by dx. So if you put that 1 by 1 minus n into dz by dx plus this y to the power 1 minus n is nothing but z, so it will be just pz is equal to q. Okay, so now if you rearrange this equation, then you will get dz upon dx plus 1 minus n pz equal to q into 1 minus n. Okay, so this is, now we have the Leibniz form of this equation, and this is the differential equation of z. Okay, instead of y, it is converted now into z, and this is now the Leibniz form. So what is the coefficient of z here? Is 1 minus n into p, and instead of q we have this q into 1 minus n. So instead of q we will treat it as q into 1 minus n, and instead of p we will treat it 1 minus n into p, and instead of y we will use z. Okay, so now if you want to find out the integrating factor from here, you will get just y integrating factor. If you want to find out the integrating factor, then you will get here to the power integration, instead of p dx you can use 1 minus n into p dx, 1 minus n into p dx. Okay, so this is how you can solve, and you can understand better with an example also. So this is the procedure. Actually I have told you here the procedure how you can convert this equation into this form, into Leibniz form. Okay, Leibniz form, where there is nothing in the coefficient of dz upon dx. You can see here in the Leibniz form that there is no coefficient here. Okay, so you have to always rearrange the equation in this way, such that there is no coefficient of dz by dx. Okay, and obviously here this should be the function of x. There n is just a number, so this will not affect the functionality of x. Okay, so you can just multiply by 1 minus n, so that will be a coefficient of z, and that will be right hand side. Okay, so let me solve this. Let me tell you how you can solve by using this method. Let me take a differential equation. Okay, so let me take an example that you can understand better. Okay, so let me take an example. as x dy upon dx, x dy upon dx plus y is equal to x cube y to the power 6. Okay, so you can see that here this is y to the power 6, you can see. Okay, so you have to take this y to the power 6 into this side. Before that you have to divide this whole equation by x also, because here the coefficient is x. So you have to divide the whole equation actually by x y to the power 6. So if you divide the whole equation by x y to the power 6, then what you will get? You will get y to the power minus 6 into dy by dx plus 1 upon x, and if you divide by y to the power 6, then you will get y to the power minus 5. Okay, is equal to x cube. Now what you have to do, you have to put this y to the power minus 5 is equal to z. You can see in the previous case that we have taken that this y to the power 1 minus n as z. Okay, so here also we have to take this y to the power minus 5 as z, and here this 1 by x is nothing but p, you can see from here. Okay, so you can see from here, this is p just. Okay, so we have to take that y to the power minus 5 is equal to z. Now if you differentiate, you will get minus 5 into y to the power minus 6 into dy by dx is equal to dz by dx. So we need y to the power minus 6, y to the power minus 6 into dy by dx, and that is nothing but minus 1 by 5 dz by dx. So let me put here. Okay, so instead of y to the power minus 6 dy by dx, we can write here that 1 upon 5 dz upon dx, and this y to the power minus 5 is nothing but z, so it will be 1 by x into z equal to x cube. Now if you multiply this equation with minus 5, then you will get just dz upon dx is equal to minus, so you can write it in this way, plus minus 5 by x into z equal to minus 5x cube. Okay, now this is the Leibniz form of first order differential equation. Okay, so what is the integrating factor? So you can write here as the integrating factor if is equal to e to the power minus integration p dx, and here p is nothing but e to the power integration minus 5 by x into dx, integration e to the power p dx. So that will be e to the power minus 5 into dx by x, dx by x integration, and integration dx by x, you know, ln x, so e to the power minus 5 ln x. Okay, so it will be nothing but, the integrating factor will be nothing but e to the power ln of x to the power minus 5, so that will be just x to the power minus 5. Okay, so your integrating factor will be just x to the power minus 5. Okay, so now you have to put in your general solution that we have. The general solution is y into if. So here instead of y we should write z, because this is solution for z, that is dz upon dx. So this will be solution for z, so it will be z into if equal to integration q into if dx plus c. So this is the general solution, but here the solution is for z. At last you have to convert this z in terms of y also, but let me first solve this equation for z. Okay, so z into integrating factor is x to the power minus 5, so it will be just x to the power minus 5 is equal to integration, we have what is q is here minus 5x cube. Okay, minus 5x cube, so it will be minus 5x cube into x to the power minus 5 dx plus c. So we will have z x to the power minus 5 equal to minus 5 integration x to the power 3 and here x to the power minus 5, so it will be x to the power minus 2 dx plus c. So you will get minus 5, this will be x to the power minus 2 plus 1, will be minus 2 plus 1. This minus minus will be cancelled out, plus c. So you will get here 5 x to the power minus 2 plus 1, that will be x to the power minus 1 plus c. So you will have z x to the power minus, let me check. So you have yes, z x to the power minus 5 is equal to this. Okay. Yes. So now you have to put this z as y to the power minus 5. Okay. So to put this z as y to the power minus 5. So here it will be y to the power minus 5 into x to the power minus 5 equal to 5x to the power minus 1 plus c. Okay, so this will be a solution. So what is our mistake, I think? Yes, when I have divided this equation by x, so this will be x square. So please correct it. Okay? This will be x square. So your q will be changed. Okay, so this will be x square. So in that case, this will be minus 3. It will be minus 3 plus 1. It will be minus 3 plus 1. So it will be x to the power minus 2 divided by 2. Divided by 2. So this will be the solution. Okay, so please correct it. Okay. So this is your solution. So this is how you can solve the problems involving the Bernoulli equation. So you have to convert the Bernoulli equation into Leibniz form, and then you have to use the general rule, as you know, y into I is equal to integration q into I dx plus c. Okay, thank you.